are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So now in this video, we'll start our discussion talking about what exactly is a thread. Okay, so by understanding or by definition, we say that thread is an execution unit that consists of its own program counter, a stack, and a set of registers where the program counter mainly keeps track of the instructions which to execute next, right? And a set of registers mainly holding its current working variables, and a stack as well that contains the history of execution. Okay, so thread is also a execution unit, okay, which has its own like a program counter, a stack, and some I would say set of registers as well. Threads are also known as lightweight processes. Okay, so nowadays threads are a very popular way to improve the performance of an application through parallelism. So threads are basically a way in which you can perform a task parallelly. Okay, they are mainly used to represent a software approach in order to improve the performance of an operating system just by reducing the overhead thread that is equal to a classical process. Okay, and the CPU basically switches rapidly back and forth among these processes, which gives the illusion that the threads are running in parallel, but actually the thread is just continuously switching between different threads about which to execute. So think of it this way: a thread is a flow of execution, okay, through the process code, which has its own stack, set of registers, program counters as well. Now, a thread shares with its peer threads few information. So there are threads working in parallelly. So they can share information like code segment, data segment, and open files as well. And one thread basically alters the code segment, right? All the other threads get to know about it. So they are kind of looking at a common code segment over here. Okay, and like in the other line, it says thread is basically a lightweight process over here, and it is basically used to improve the application performance. Okay, and each thread exactly belongs to one process, and threads do not exist out of a process. Now, one thing that can come very easily over here is that if this is what a thread is, then what exactly is the difference between a program, a process, and a thread, right? You may ask that question over here. So, program we've already discussed, and process we have already discussed. Okay, program is something which is nothing but a set of instructions, right, in a executable file, right, which is present in the secondary memory, correct? And when that process basically comes into the main memory, right, it gets converted into a process. Okay, that's what the definition of a process is. And when it comes to thread, thread is the smallest executable unit of a process. So it's like a process divided into multiple threads. So thread is a smallest executable unit of a process. For example, when you are running a notepad program, the operating system creates a thread, creates a process, and starts the execution of main thread of that process. So you have like a notepad exe, which is a program. When you start running this, it basically becomes a process, right? And after that, what happens is the operating system starts the execution of the process with the main thread of this process. Okay, now a process can have multiple threads. It's like a process broken down into subparts known as threads. Okay, so that is why a process can have multiple threads. Each thread will be responsible for their own task and own path of execution in a process. So I will say that here, when we divide a process into threads, right, each thread will have their own task assigned to them. They are responsible for a particular part of the process. Will their own task, right? And they have their own path of execution as well. Okay. For example, in the Notepad program, let's say one thread is responsible for taking user input. Okay. The other thread, let's say, is responsible for printing document. So different threads have their different task or responsibility assigned to them. Okay. All the threads of a single process share the memory of that process. So it's not, so every process has its own program counter, set of registers, right, and stack as well. But all the threads of a process, apart from that, all the threads of a process, okay, basically share the memory of that process. That means all processes share a common memory. Okay, that is why as the threads of the same process share the common memory, the communication between threads is fast. Okay, as we can say that threads of the same process basically share the memory, we can say that communication between threads is quite fast. Okay, and then we logically break down a process into threads, and all those threads can actually I would say execute parallelly, because of which it's easier or faster to execute a process. So it's like a process and it's divided into thread 1, thread 2, thread 3, and so on. Okay, and you can have multiple processes as well. Okay, so process is basically a heavyweight operation. Okay, inside a process we have multiple threads, which are lightweight operations. Process is also responsible for executing a task or a program, but it's a big program, whereas a process gets divided into small threads, and threads also perform a task, but it's a lightweight task over here. Okay, so if I have to draw a logical differentiation table over here between a process and a thread, it would go something like this. Okay, so when we talk about process is basically a heavyweight operation. But whenever we talk about threads are also responsible for doing the operation, but they are usually lightweight operations. Okay, whenever we talk about process, each process has its own memory space. This is point number 1 only. Whereas when we come to threads uses the memory of the process only they belong to. They don't have their own memory. Okay. Inter-process communication is slow as different processes have different memory addresses, correct? If you have to communicate between two processes, it is possible, but it's going to be a little bit of a slow operation. Why? Because different processes have different memory address. Different process has different memory address. Okay. Whereas when we say inter-thread communication, okay, is fast. That means for all the processes of a thread, or for all the threads of a process, the communication between them is going to be faster as the threads share the memory of the process they belong to. Communication between threads of a process is faster as they share the memory address of the process they belong to, and hence faster communication. Okay. Here, if you are switching from one process to another process, okay, if you are switching from one process to another process, then remember that the context switching is going to be more expensive between processes. Whereas in terms of threads, right, context switching between threads is less expensive. Context switching between threads of the same process is less expensive. Okay. Here, processes, like we've already discussed, does not share memory with other processes, whereas threads basically share the memory with the threads of the same process. This is what typically a difference between a thread and a process is. Okay. From today, you should not have any difficulties understanding what a thread is and what a process is. Okay. A thread is a single sequential flow of execution of tasks, right? So that it is basically a process broken down into multiple threads. Okay. That is what the overall idea is, and that's what the definition says. So the CPU rapidly switches between the threads, which gives the illusion that the task is happening parallelly, but actually it's just happening sequentially only. Now, as each thread has its own independent resources for the process execution, thus multiple processes can be executed parallelly by increasing the number of threads. So each process has its own independent resource, right, for the execution of a process. So if you have to execute multiple processes, you can increase the number of threads as well, which will increase the overall the parallelism and the execution of the task as well. Okay. Think of it this way. You are on the browser. Okay. Take this example. You are on the browser, and in the browser, many tabs are basically open. Okay. So the entire browser window is a process, right? Because from chrome.ext, you executed that particular program and it became process. But the multiple tabs on that particular browser is basically threads. Okay. So each tab on a browser is basically a thread. Okay. Similarly, if you're using Microsoft Word, in Microsoft Word also you have different threads. For example, formatting the text is happening through one thread. Processing the input from the user is happening in another thread, right? Printing the doc is basically happening on another thread. Okay. So what exactly is the need, right? Why do we need process? Because it takes less time to create a thread, right, in an existing process than to create a new process altogether. Okay. Then threads share the common data. So the inter-process communication is slower, but inter-thread communication is faster. Context switching, like I said, is also faster, and it takes less time to terminate a thread as compared to the time it takes to terminate a process. Okay, and threads provide a suitable foundation for the parallel execution of applications on shared memory multiprocessors. Okay, so there can be a multiprocessors which have a shared memory, and in those situations, thread provides a fast way for the execution of the code. Okay, that's what the overall idea is about like a thread, the difference between a process and a thread, what are the advantages of using a thread. Okay, I'll write down the advantages also over here for you to understand. So whenever we talk about the advantages, the points above are pretty much concise. Thread basically minimize the context switching. Secondly, right, it provides concurrency within a process. Okay, along with that, there is efficient communication. Inter thread communication is fast. Okay, along with that, it is more economical. And faster to create threads compared to different processes. Okay, and here it allows the utilization of a multiprocessor architecture to great scale and efficiency. Okay, so that is what is the overall idea whenever we talk about the concept of threads. Okay, and these are very, very important points, because this threads, like I said, form a very suitable and an important foundation for the concept of parallel execution of your applications. So if the idea regarding this is not clear, it is bound to happen that you will get confused about what exactly is the overall idea and how does this concept really works. So make sure your understanding is absolutely clear about what a thread is, what is the difference between a thread and a process, and what are the advantages of using a thread. Okay. Next, what we are going to talk about is what is a single threaded process and what is a multi-threaded process. So in the next video, we'll take our discussion to start with the difference between both of them, and then we'll basically have a more tabular, and I'll add some more points to the discussion to talk about a difference between a process and a thread. Okay, so that would be the discussion for the next video. But for this video, we've completed 3 points already about what is a thread, right, and what exactly is the difference between a process and a thread, and then we talked about what are the advantages of using a thread. Right now, in the next video, we'll talk about what a single threaded process is, what a multi-threaded process is, and then followed by some more discussions on the models related to thread. All right, so stay tuned in for the next videos as well, and thank you so much for taking a look at the very first video of threads. Thank you.